Alright, so this is Sergio, Drivetrain Lead. I just want to go over a couple of tips on how to go about with designing and creating the gearbox. I designed and built the one for the 2020 car, and so I'm currently having some other students and members working on it. So kind of wanted to show them a couple of tricks and tips that I did that I used to be able to develop the gearbox. So a couple websites that I used. The first one was Gear Generator. So if you just type in Gear Generator, it's geargenerator.com. It's a good place to kind of set a bunch, try different parameters, see what your center distances are, and things like that. It's a fun little website that someone created. So it starts off by giving you these 4 different gears that you can use. So we're just gonna change this as like an internal, kind of like a internal ring. So we're gonna do external on this one. Change that up. And so one thing that you can do is we're gonna be using our gear calculation code to determine what our face widths are, and we're also gonna use our Baja vehicle simulation code to be able to determine what our gearbox ratio needs to be. So when you put gears in this configuration, this last ratio right here, which as you can see right now is a 10:1, this is going to be your gearbox ratio that you're going to wind up using. So there are a few limitations as to what we can do. If you're working on your gearbox for your team, then you're going to know like what your input shaft is going to be. So depending on how large your input shaft is, you're going to know what distance you can go from the edge of your input shaft to the valley between your teeth. So I don't know what that might be for your team. We have a specific distance that we are comfortable going to. You have to do some analysis to determine that you have enough wall thickness between the edge of your input shaft and the edge of your teeth. So just make sure that you check what that configuration is going to be. And then for us, using our face width calculations, we're going to be able to determine what our diametrical pitch will be for our gears, whether we're going to do one pitch for the first reduction and another pitch for the second reduction, or if we're going to use the same pitch for the entire gear train. That's also a possibility, something that we did last year. So the way that you work this is basically you select how many teeth you're going to have on your first one. So we're just going to say 16 teeth. And let's say that we're going to use a diametrical pitch of 10. And so you'll also know what diametrical pitches are applicable to your specific gearbox that you're going to work on. There's 2 different main pressure angles that are used. I think one of them is 14.4 and the other is 20 degrees. So we're going to use 20 degrees in ours. And then let's say that for the second one, we're going to use a teeth of a 40 tooth gear. So that's our first reduction. So as we can tell from our first gear to our second gear, that reduction brings that original ratio to 2.5:1. And so now we're going to work on the second reduction. We use a double reduction gearbox, so this is going to be our second reduction. So on this one, let's say we're going to use another, maybe like a 17, and let's say that we're going to keep a 10 pitch also for the second one. And then if we want to get down to, let's say, like a 7:1, then we can just bring this teeth down till we get down to that 7:1 or somewhere close to it. So you can play around trying to figure out what number it is. You can also do the calculations to determine what gear train you want to do. So one thing to know here is that you're also going to have certain limitations as to what your center to center distances are. Specifically, I think mainly from the input to the output. If you're running CV joints and you're running a CVT on the secondary, which is the input of this gear, then you got to make sure that the secondary outside diameter doesn't interfere with your CV joints on the output, or maybe if you're running U joints, make sure that those don't interfere either. So that's going to be something that determines what your center distances will be between these. So you might need to either step up the pitch or be a little creative as to how you're gonna have there not be any interference between the parts that are attaching to this. So a gear generator is just a really quick way that somewhere where you can go really quick to put together a specific gear train and determine those center distances. So if we want to know the center distance, we can know that if I select this one gear right here, I know that so you have the pitch diameter, which is in inches here. That's basically the diameter, this line that runs right here, which is where the teeth mesh to the next gear. So the center to center distance from this gear to this gear, to this gear will be the radius of this plus the radius of this gear. So if we know that this is 1.6, we know that the radius is 0.8, and then on this one, the pitch diameter is 4, so half of that is 2. So the center distance from this first gear to this second gear is going to be a 2.8. So then you have that 2.8 to here. Then you would do the exact same thing to here. So on this third gear, you have a 1.7. I'm going to round it up to 1.8 just to make it a little bit easier for us. So if I have a 1.8, I know that the radius is 9.9. And then on the last one, the pitch diameter is 4.8. So I know that this is going to be a 2.4. 2.4 plus 0.9 is going to be 3.3, I think. I'm sorry if I'm wrong on that. So then 3.3 plus the 2.8 here that we got was, oh, it's hard to do it in my head. Let me write it down really quick. So we have 2.8 and what did I say here? We have 2.4, 3.3. Alright, so 3.3. So we have 6.1. So we have a 6.1. So our total center to center distance from the input gear to the output gear is going to be 6.1 inches. So that kind of gives you an idea as to what your center distance is. Those are going to be super crucial for when you're designing the case, because if those center distance are even a little bit off, you're going to have interference issues. There's going to be, the teeth are not going to mesh correctly, and pretty much your gearbox won't work then. So just wanted to show you gear generator to show you how to determine those center distances. So I'm going to select a center distance and some gears right now so that we can design something in SolidWorks. So I'm going to pick some easy numbers here so that way it's easy for us to calculate it. So I'm just going to go here to 40, and I'm going to do 20 on here. Maybe a super small 40 again here, and I'll do 20 here. So that's super simple. Our full reduction is 4:1, and so I'm gonna write down on a piece of paper that I have right here next to me what the center distances are, and also what my diametrical pitch is for those gears. So for gear 1, I have a 20 teeth. I have a diametrical pitch of 10, and then I have a pitch diameter of 2 inches. So I know that I have a radius of 1 inch. And then for the second gear, I have 40 teeth. I have a 10 diametrical pitch also, and I have a 4-inch pitch diameter, so that means I have a radius of 2 inches. So I know that the center distance between the first and the second gear is 3 inches. And so now for the second gear, I have 20 teeth again. I have a 10 diametrical pitch, and I have also 2 inches. So that means that my radius is 1 inch for that one also. And then for the last gear, it's exactly the same. 40 teeth, 10 diametrical pitch, 4-inch pitch diameter, and 2-inch radius. So from the second reduction, the third gear and the fourth gear, the center distance is also 3 inches. So that means that my my center distance from the first gear to the last gear is a total of 6 inches. And I would just record also like what my reduction is, which in this case is going to be a 4-to-1 reduction. And so that's kind of the information that we're going to need, at least for the meantime, to be able to determine how we're going to structure the SolidWorks design. All right. So again, number of teeth. This pitch diameter is this line that runs along the outside. It tells you what the diameter is of where the teeth meshes with the other gear. And then diametrical pitch is basically how many teeth per inch there is on this gear. And then the pressure angle is basically the angle that the teeth are formed in the type of involute tooth that it's using. Alright, so that's like a little intro to Gear Generator. Play around with it. Super fun. You're able to like speed this up if you want to like 100 RPM and see how it runs. It's pretty cool. Play around with it. So now I'm going to go on to explain how to design gears and determine what the OD of those gears are, because we're going to need that information too. Alright, so now that we went over the gear generator, we want to know how to design gears. So for everyone has, I guess, a different way of designing gears when it comes to like parametric CAD modeling. Some people use SolidWorks. I know some schools use Masta. Some schools use ProEngineer. Different people use different programs to make their gears. And so this video that's playing in the background is a video that is on the Cal State LA Makerspace YouTube channel. This is Dr. Bachman going over how to create or make gears with involute teeth in SolidWorks. It's a great tutorial. If you've never made gears, definitely go check it out. It's really intuitive. I think he even goes over using tables to make these gears, so then it could be super customizable. It's definitely a great way to learn how to make involute teeth manually, or like by hand, I guess is one way to say it. In SolidWorks, definitely go check it out. I'll link to it in this video. I know SolidWorks also has a toolbox, I think, for gear generating, so that's also another way that you could do it. If you're really in a pinch or you really want to get something done really quick and you don't have the time to go through this, which sometimes is the case when you're designing for Baja. Sometimes there's like quick changes that you have to do. Gearbox ratios change, your code gets better, so you realize you're in the wrong gear ratio and you have to absolutely make a gear in a couple seconds. There are plenty of places online that you could download CAD models for gears, and so I'm just going to show you one that I've used and has been pretty reliable. We're not sponsored by this place, but hey, Rush Gears, like, we'll take a sponsorship any day. So one place I use is rushgears.com. I've shared this with some of the people on the team. So under their design tools, they have a 3D CAD, and so what they basically have almost every every gear possible. So you basically define it by the diametrical pitch. We're doing a spur gear. Material doesn't matter. You can also order gears from Rush Gears, but we're not really. All we care about is the model. So you select the pitch. It has almost all the common, most of the common pitch threads. We're using 10, and then so right now we're gonna do our first gear, which is a 20 tooth. So we're gonna go down to 20, and then they have this thing called PA or style. So if you just hover over PA, it'll tell you like what that means. So I think we mentioned earlier there's two different pressure angles that we commonly use. One of them is a 14.5. I think it has a 14.4 earlier. It's 14.5 and a 20-degree pressure angle. So under pressure angle, we technically use we usually use a 20. And then when it comes to style, it tells you right here what kind of style they have. So they have a style A, style B, style C. So it's just basically that little face that they add, that little boss that they add at the end, in case if you need a little bit more meat on your gear. So I usually just download the A. If I need to add any other features to the gear, then the good thing about getting them from here is that the CAD model is completely customizable. So I would just select the A, go to CAD, and then I'm going to get 3D. You can also get a 2D drawing if you're taking it to maybe a machine shop that's going to do it, or a broaching shop that's going to do it for you. You can just get the 2D drawing and you can forward that over to them. So I go ahead and download the SolidWorks file since I'm working on SolidWorks. I get the 3D file and I save it to somewhere. I'll save it on my desktop for right now. And so now I have that 17, or I have a 20 tooth in 10 diametrical pitch that is ready to be worked on in SolidWorks. So at the same time, I'm going to download while I'm here. I'm going to download the 40 tooth that I also need. So I have a 40 tooth here, and I'm just going to download the first one also. Get 3D file, and I'm also going to send this to my desktop. And then I have both of the gears, since all four both reductions are exactly the same. I just need 2 gears. If you're making a reduction that has 4 different gears, then you would need 4 different CAD models for this. So this is an easy way to get your gears. Rush Gears, great place to go. Rush Gears, we need a sponsorship. We need gears from you guys. Reach out to us. All right. Another thing that we're going to need that you can get from Rush Gears is going to be the OD of the gear. So we talked about the diametrical pitch. The diametrical pitch is the pitch of where the teeth mesh, but the teeth goes beyond the diametrical pitch. So I'm sorry, not beyond. It goes beyond the pitch diameter. So we had said that the pitch diameter for a 20 teeth is 2 inches, but the OD is actually 2.2 inches. So we want to know that also. So make sure you write down what your ODs are. So for the 20 inch, our OD is 2.2. And then for the 40 teeth, it is 4.2. Alright, and we're going to need to know that because when we build our case, we need to have some clearance between the edge of the case and the edge of the gear. So we're going to need to give a clearance past this 4.2 inch and past the 2.2 inch on the 20 inch teeth. Alright, now we're going to move on to how we design the case within SolidWorks, okay? Alright, here we go. Alright, so now I'm here within SolidWorks. I already have my ODs, I know my center distances, and so now I'm going to design my gearbox. So I'm going to start off with the bottom case. So we usually have a gearbox that's composed of a top case and a bottom case. So I'm going to work on the bottom case today. And so I'm going to begin with that very bottom lid to begin with first. So I'm going to start a sketch in SolidWorks. And so I start a sketch, and I'm going to work on the... So I guess it's important to a certain extent what plane you start on, because eventually we're going to bring in this gearbox into the CAD model of the car. And so depending on how you orient the gearbox at this point. Sometimes you want to make planes or you want to make certain places, and it's good to maybe orient your gearbox in the correct plane. So that's up to you, however you want to do it. You can always create reference planes down the road if you need to mate to a plane. So I wouldn't worry too much about it, but I mean, if you want to be very precise in how you're going to design this, and if you're thinking ahead at the beginning of this build, then by all means find out what best plane is appropriate for your gearbox. So we're going to start off on the top plane. So if you click on the top plane, we're going to start by creating a couple of circles. So we're going to start off with the first circle. I'm just going to go off of this line. Actually, let's start in the middle. So we're going to make this our second reduction. So this is our second gear, which is the 40-tooth one. So our rule of thumb and the way that we have done it in the past is we add 1/8 of an inch all the way around our gears as clearance from the gear when it rotates. So if I know that my OD for my gear, I'm pulling on my calculator. If I know that my OD for my if I know that my OD for my gear is 4.2, then I'm gonna add, if I want to leave an 1/8 inch clearance, I need to add an 1/8 inch clearance on the top part and also on the bottom. So that brings it up to 1/4 inch all the way around. So I'm gonna add 0.25, and so I know that my OD now for this middle portion has to be a 4.45. So we're gonna do 4.45. So that's the size of the hole for the first. That's the size of the case for the first one. And so now I'm going to create another circle for the gear that's going to go in front of it, and I know that that is going to land somewhere over here. So I'm going to add another circle, and then that circle is I know that the OD for that circle is supposed to be 2.2. So same thing, an 1/8 inch clearance all around. So if it's 2.2, I'm going to add that 0.25 since it has to be on each side. And so that gives me an OD of 2.45. So I'm going to give it, sorry that my computer keeps doing this, but this is recording is and doing this is very graphic intensive. So that's why my computer doesn't really like that I'm doing this at the same time. Okay, so now I have those two circles there. And now what I want to do is I want to make that center to center distance exactly what we had said earlier. And so the center to center distance between the first and second gear is 3 inches. So I'm just going to grab center to center, and I'm going to make that 3. So I hit 3. And so now I know that those two are the center to center distances are exactly where they're supposed to be. So now I know that on top of this 4-inch gear that I have here, I also have another 2-inch gear that goes on top of that, but then that 2-inch gear then goes meshed to another 4-inch gear. So I know that I have another 4-inch over here on this side. So I'm gonna grab another circle and I'm gonna follow this same horizontal line, and I'm gonna create another gear that is 4.45. Right, because we know that the OD for this one is 4.2, so we're going to add that 0.25, so that's 4.45. So we have that hole there, and then now what I want to do is I want to make this center to center distance correct, and I know that that center to center distance is 3 inches. So I select 3, and now I know that all of these are correct. Now, I still have blue lines, so that means that I haven't constrained. There's some stuff that's not constrained, and I think it's because they're not constrained vertically, so we can try to do that now. I mean, they're not constrained horizontally, and so then I select this one. Alright, so now all those are constrained. Now, this is where your creativity and also your how you basically your analysis on the case I know some people are using, like I mentioned earlier, are using Masta, and so Masta is able to give you a lot of information as to how you're supposed to design your gearbox and stuff like that. If you try to do FEA analysis on your gearbox, then you can determine like what kind of design and shape that you need to have it be. But basically, what I want to do is I want to connect these together. And so there's many different ways that you can go about it. I know that these two are together, so I'm just going to pick this top line and then just connect it to this bottom, to this portion here. I'll do the same for the bottom one. Again, you're going to be designing this. Your design is going to be different than mine. And then I'll pick like a perimeter circle, and I'll just go from here to here, and then just to create this, join these two together. So I'm going to make this a nice number. Let's just say 6. Sorry again about my computer acting like this. Another perimeter circle. Oops, that was not right. So another perimeter circle. One here, and then we'll make this 6 also. And so now let's go ahead and start trimming stuff. I want to constrain this line, since it's still blue, to this point. Then let me do that. So here to here. Do the guys to this. Sorry about that. Okay, that's fine. And I'm going to do this to this one. Sorry again for that. Oh, come on. Smart dimension from here to... Oh, did it do it? Oh, yeah, I got this last one. Okay, cool. So nothing's blue. Everything is good. So let's trim some edges. I'm going to trim this, trim this, trim this, trim this. I'm going to trim this, and trim this outside, and trim this outside, and now I have my shape of my gearbox. So I know the 2 gears fit here, and then the small gear up here. So now I'm going to exit sketch, and now I'm going to extrude that sketch. So we're going to go features, extrude boss base, and then like I said, you do your FEA, you do your analysis, and determine what the thickness of your gearbox needs to be. So just for the sake of argument, I'm going to use 25 1/4 inch thickness, and that's how I'm going to make the thickness. So I know right now that at the edge of this gearbox that I have here, I know that if I set my gear in here, another gear in here, another gear in here, I know that I have enough clearance up to this edge. So now what I want to do is create the walls that are going to go around this. So what I'm going to do is I'm going to use this this bottom plane as where I'm going to start drawing. So I'm going to do extrude boss base. I'm going to select this bottom portion as my plane, so that way if I decide to move that bottom portion up or down, then the walls will follow along with it. And so I'm going to do center 2, or normal 2, I think is what they call it. And I'm going to convert entities. I'm going to convert all these edges that I've created here. So just select all these edges that we've created. Okay, now we're going to convert those. So those are now lines. And then I'm also going to do offset entities. So I'm going to select this first one, and I want it to be, since we did the bottom 1/4 inch, let's do the wall thickness also 1/4 inch. So here you can see the little yellow line going across. That's my offset entities. And now I can, I've created that. So I have this wall now that is going all the way around. And if I exit sketch, now it allows me to it allows me to extrude that portion up. So depending on your face width, we use our face width calculator code that we've done to determine what our face widths need to be. Once you have that all stacked up, then you know what your thickness of your gears are. And just like on the edge of your OD that we left an eighth of an inch from the edge, we're also going to do that with the top and bottom and in between gears also. So wherever there's a gap between a wall or another gear, you want to leave an eighth of an inch distance to make sure that there's enough clearance for that. So just for the sake of argument, let's say that our gearbox was going to be 3 inches tall. So we'll make this 3 inches. And I want to go the other way. And we're going to click check mark. And now we have the beginnings of our gearbox here. So now we know that our gear should be able to fit somewhere within this space. And all the center distances are correct. So I know that my shafts can go where these middle points are at, and they'll fit in perfectly. Let's start setting some gears in here just to show you how to set gears inside here. So I'm going to file, I'm going to save as, and I'm going to call this on my desktop, I'm going to call this case bottom. And so this is the workings of your case. Once you determine where your frame points are going to be to mount this on your frame, then you can come back in here and extrude some bosses so that you can set your frame where your frame is going to bolt onto where your case is going to bolt onto the frame. And then we're also going to come back in here and create screws so that we can screw on the top case on this also. So now that we have that saved, let's open up an assembly. So we're going to go File, Open. We're going to create an assembly. Oh, sorry. File, New. We're going to create an assembly. Alright, once we're in our assembly, we're going to bring in that case bottom. We're going to open. My little green button is hidden back here behind this thing. Alright, so you hit that little green check mark and it'll orient it according to the plane that you originally created it in. And so we have this here. So now we're going to bring in our gears. So I'm going to bring in rush gear. So you can see how they label it. It tells you what year SolidWorks that you downloaded it in, and so I downloaded it in 2017. And then it says F1020. So that's gear with a 10 diametrical pitch, 20 teeth. And this bottom one is 1040, so that's 10 diametrical pitch and 40 teeth. So I'm going to bring in this 21. And so then it brings in this nice teeth here, nice gear in here. So we can scope out what that looks like. And so that's kind of what it looks like. And so maybe something that I would have liked to do before is maybe create the shaft holes here. Because if I create the shaft holes, then I can mate these holes to that hole. So you know what? Let's just go ahead and do that to make our lives a little bit easier. So I'm just gonna open up that case bottom by itself, and I'm gonna do extrude cut. And if you know like what the hat sizes are gonna be for your gearbox, then I mean, might as well start doing it that way. So I'm just gonna I already know exactly where my center distances are, so I'm just gonna create my holes there. So I know that it's at the center of this hole right here. All right. Then I'm gonna do smart dimension here. So I'm just gonna make this an inch since we're almost there. And I'm gonna make these all equal. Right. Maybe making it equal is not the best option, right? Because these might wind up being different sizes. But just to show you guys, I'm going to make them equal. I didn't cut all the way through, so let's open this up again. And we're going to go through all. Beautiful. Now we have holes. Let's save that. And let's get back to our assembly. Yes. Alright, so now we have our assembly here, and it has those holes already lined up. So, depending on your configuration, this might be closer to the top or it might be on the bottom. Whatever it is, you can configure it the way that you like. So, like I mentioned earlier, I want to make sure that when I make this gear to this face, I want to make sure that it's not coincident. You want to make sure that there's a distance between them, and the distance is going to be 0.125, or that 1/8 inch for us. You do what you guys do. We do an 1/8 inch. It's worked for us. And then what I'm going to do is that this shaft hole, I'm also going to make it centered to that hole there. So then that is the placement of my first gear. So this gear is not fully constrained. As you can see under here, it's still underdefined. I might make a tutorial how to do like an advanced mate so that all your gears spin and stuff like that. Not sure how far I'm going to take this, but just showing you guys how to do it at this point, just a basic setup of the gearbox. So then we have this gear. So now let's bring in the next gear. So insert component, and we're going to bring in our 40-tooth gear. Nice 40-tooth gear. Same thing. Sorry, I accidentally hit insert component. So when we're gonna mate this one, like I said, think about your design intent. If you move this gear, maybe you want this one to move. So maybe what I would do even is I would hide this for a moment, and I would mate like this face. Make this face to the bottom of this face. Just so that like if I move this gear up or down, this one just follows with it, and that might be something that you might want to do in as part of your design intent. So now we're gonna see the case, and now the last mate that I want to do is all right. Let's bring this up and let's mate this correctly now. I don't want that face, I want this bottom face. Okay, that face, and we're going to mate it to this. And like we did earlier, a distance of 0.125. And now that that's good, I'm going to do the center of this hole and the center of this hole. And then those should be concentric, and then we're going to check mark it. And then everything should be happy. So it's all happy now. Alright, so it's kind of hard to tell, especially because they're not mated correctly. But if we kind of move these around a little bit, you can kind of tell that the faces are kind of meshing correctly. There's a little bit of interference, but that's just because we don't have they're not exactly right where they're supposed to be. So we can go into an advanced mate later on, and I can show you guys how to sync those up nice, and so that they rotate in sync. All right, so we have that gear there. So now we know that this one is good. This one is good. I didn't mention earlier, but as you can see, because we left that 1/8 inch here on this side and all the way around, there's plenty of clearance all the way around our gear. Some of you guys might be like, why are you doing the whole 1/8 inch? That might be too much. It's just what we've used. Leave it in the comments if you guys use something crazier than that. I mean, more power to you if your gearboxes work and you guys leave less. I'd be interested to see how small you can get. I think it's an 1/8 is pretty close. Maybe you might think that we're crazy. I might even go a little bit bigger just to be a little bit safe. In case of like a tooth breaks or something like that, maybe your gear doesn't completely destroy the case, and you can still salvage the case, whatever is the case. No pun intended. I would like to hear like what other teams use and stuff like that. All right, so let's insert the second reduction. So we're gonna do that 20 tooth gear, and this one's gonna sit right on top of this this gear here. So we're gonna mate. Now this one doesn't need to have any clearance between that gear and this gear. They can sit right on top of each other. And so now we're gonna pick the outside of that hole. And then we're also going to make it concentric to this one. And so that sets that gear on top of there. Alright, and now we're going to bring in our last gear. So let's bring insert component, and we're going to bring in our last gear, which is that 40 tooth gear. And we're gonna set that. So we're gonna want this one to sit, because it's going to hover over this gear. We want it to mate with this face, but we want to leave that distance again of 0.125. Alright, and so we have a distance. It's not directly on top of it. There's a little bit of a gap, right? And now what I want to do is make this one also mate this one to this hole, and I'm going to check mark it, and so now I have my entire gear train on there. Alright, so I'm going to hide the case, and so as you can see, this has an eighth between the bottom of the case. You can't see the case right now, but we left an eighth between this one. There's a lot of space between this one, right? We have at least this gear thickness above this one, and then we have an eighth between these gears, so we won't have any issue of those. This gear is taller than this gear. I would bring this gear down to this size, just because there's really no point of having this gear. It's not in bending, or it's not being stressed when there's nothing meshed to it. So you want to make sure that this gear is at the max at the top of this gear and nothing above it. And that's that you do in your gear analysis. Alright, and so let's unhide the case. And so, alright, so let's find out how tall that is actually. So let's evaluate that. Let's measure from here to here. Sorry, from here to here. We have, 125. How funny. Alright, so let's open up this gear, the big gear, and we're going to make that smaller. So, like I mentioned earlier, Rush Gears makes it easy. Everything is customizable, even the bore size on this. So we're going to change the gear body. We're going to change this extrusion, and we're going to cut it down by 125. So this is going to be, this was 1 inch, so we're going to do 0.875, and we're going to check mark that, and we're going to save, and we're going to go back to our assembly. Okay, so this is actually a really great time to save. So we're going to call this Gearbox assembly. And you guys can kind of already see how these are lined up. So that's why I asked me to save, because I accidentally hit the X. So let's do GB assembly. Open that up back up. All right. So now that we're in here, we know that These are now lined up. Everything has an 1/8 inch of a clearance. The only thing that doesn't have an 1/8 inch of a clearance is this top case to this bottom one. This where the top case is going to sit. So let's find out how thick that is, or what the distance is from there to there. So it looks like that distance is 0.75. So if we only want to leave an 1/8 inch of an 1/8 inch of distance, we're gonna need to remove 0.625 off of the case. So let's open up. I guess technically you don't have to open up that case. We can do that change from here. So it would be on this boss extrude. So we're gonna open up that boss extrude, and we had 3 inches. So if we subtract the 625 from 3 inches, we get 2.375. So that's how thick this has to be. So 2.375, and then we hit enter, and we check mark it, and we exit edit component, and we save it just in case. And so now if we check if we measure from here to here, we have that distance of 0.125, which is exactly what we wanted. So now we know that all our gear train here has the right clearance all the way around, top and bottom. Now all I would need to do is make that top case, the case that's going to sit right on top of this. Before I would do that, I would create the bosses that are going to have the tapped holes where I'm going to screw into it, and then I would create the top case. So I'm just going to create a couple of them just so that you guys can see how to do it. And that'll be the next video, or that'll be this next portion. Alright, so we got the outside of our box set up. We got the walls, we got all the thicknesses correct, we got all the clearances correct. So now what we're going to do is we're going to create the little bosses where we're going to secure the top case to. So what we've been used to doing is using 1/4-20s to secure the top of the case. So I like to use like maybe like at least like a 0.75, like a 3/4 inch boss to drill the hole and tap the hole. So we'll do that. You do what you think is best for your case, but I'm just gonna do this for this purpose at this point. So alright, so I open up the case because that's what we're gonna work on. I'm also going to have them run from the very edge to the top. We're already assuming that we have a billet of aluminum this big that we're going to CNC. So, I mean, might as well just have that go all the way across. If you're trying to save material or save weight, it's going to be very minimal. At least I think it will. Maybe it'll be good to maybe justify that, but just to cut down on CNC time and machining time, I would just make it all the way through. So that's what I'm going to do here. So I'm going to do features, extrude boss base, and I'm going to go from the bottom also. And you're going to really find out why I go off of the bottom when I do the top case. Let's go back here. I'm going to change this to so I can see this hole. And then what I'm going to do is I'm going to use a circle, a center circle. And then what I'm going to do is I'm just going to set this and go all the way across to here. And then so that's 1/2 inch. Alright, 1/2 inch works for me. Maybe that is what I've been using. And depending on where your mountings need to go, then you put them accordingly. Alright, 0.5. I'm just going to set a few of them around here. Do one back here. Like I said, you figure out with your team what how many and the positions of them. We have figured that out. We feel comfortable with certain places to put them and where they haven't failed in the past. Maybe there's better ways of optimizing where these go. If you have a good way of determining that, please let us know in the comments. We're all trying to learn a little bit here. Alright, so I'm gonna leave it at that. I think I did plenty of them. Actually, I'm gonna delete this one because it looks weird here by itself. Alright, and so you would have more, of course. I don't think 4 is enough. A bunch of oil leaking probably. And then I'll use the perimeter circle. And then what I'm going to do is I'm going to go from here to here. Why didn't I follow here? Okay, so we need to convert entities. So we're going to convert this entity, convert this one, convert this one. Okay, so it's just going to convert the entire face, which is fine. And so now we're going to do perimeter circle. So we go here to here. We did the same thing again. Okay, one more time. Here we go. From here to here. Alright, there we go. And let's make this 0.75. Yeah, that looks good. Same thing on this side. And we're gonna make this 0.75. So there's other ways to do this. I know you're probably yelling at the screen right now that there's better ways of doing this. I'm sure there is. I know that you can make like a center line, then just mirror this one. Whatever be the case, you do you. Make your designs happen. Alright, and then I'm gonna delete. I'm gonna trim this one, and I'm also gonna trim this one. Alright, so that way we just have that little boss right there that's gonna get extruded out. Alright, I'm gonna do the same thing for this one. Okay. I feel like I can get through it fast enough by just doing this every time. But you might think that mirroring is faster, and if that's what gets you faster results, then by all means do that. Alright, so we're gonna do same trimming again. Trim here. I'm gonna trim this one right here. And I'm gonna trim this one right here. And then we're gonna trim the outside. Trim the outside. And then we're gonna trim this side. And we're gonna trim this side. So then you have that little boss there. Okay. 2 more. Probably should have only done 3 for this tutorial, huh? Alright. This one here. This one. This one. This one. We're gonna do 0.75. Do this one. 0.75. And we're gonna trim. So, you know, once you start doing this a couple times, start getting faster at it. Trim here, trim here, trim here, trim here, trim here, and trim here. And then you have that little boss there. Okay, one more. Alright. So last one. Here, boom, boom. Here. Alright, and then we go 0.75. Go here. 0.75. Dimension, exit. Oh, no, not exit sketch. Sorry. Let's exit that. Let's go back into that sketch. Trim entities. Trim here. Trim this. Trim this. Trim this. Trim this. Trim this. And trim this. Alright, so now we have all our bosses. I have some extra lines here that do not belong here, so let's get rid of those. That's because we selected the entire face as for now. Alright, let's get rid of those. And it seems like now only our bosses are selected, so let's exit that sketch. Because I didn't do it right, it only created the sketch, so we're going to do extrude boss base, and we're going to do up to surface, and we're going to do up to this top surface. Let's see everything, and then select. Alright, so it probably didn't do it because, oh, sorry, it's just I'm going too fast. Alright, so we have those there now. Alright, so you would have a few more around here. Then you can select hole wizard, or if you just want to make a pilot hole, like let's say for instance you're going to see this, it might be a good idea just to do a pilot hole or a center drill or whatever it is that you do. Maybe it might not be a good idea to do hole wizard, but we're going to do hole wizard right now. So quarter 20, and then so we select the point. So alright, so sometimes it comes out, sometimes it doesn't. So what I like to do is I'll just do a sketch, quick sketch, and I'll put these points on the sketch. So then I can select this top face, and I'm just gonna do point here. Alright, you're not coming out, point. There we go. Point. Point. Last point. Alright, and now I have those points there. Now I can do the whole wizard if I wanted to. So we got quarter 20 there. Now we can select oh, we gotta select the face, sorry, not the point. Alright, there we go. Alright. Hole, 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 hole. Alright. So these are gonna be tapped holes. Man, if you tap that deep, that's crazy. Alright, so it's not gonna be through all. It'll be blind, and it'll be, I don't know. Yeah, that's good. We could just leave it at that. You'll find out how long it needs to be, an inch or whatever long it is. And you take the risk whether you do it on a CNC or not. Or if you do them by hand. So there you have those holes there. And so this is close to being, we're really close. You need to figure, I'll do another tutorial on how to make the hats, which is what we use to keep concentricity between our shaft and our gears, and between the top and the bottom case. So I'll go through a tutorial of that later on. But right now it's just a good idea to just work on this case and figure out what gears you're going to use and stuff like that. Alright, so that's the bottom case. Now let's work on the top case. Alright, so I'm going to save this bottom case. And so the reason why I've worked off of that bottom part is because I want to make the top case from this bottom case. So I want to make sure that all of my features that I'm going to use, so for instance here we still don't have mounting holes to the frame, so there's going to be at least like 3 or 4 different places that we're going to mount this to the frame. and maybe even if you have like a rotor, or I mean a caliper that attaches to this case, then you're going to need holes for that. You want to make sure that all your features are on here before you even make your top case, because it'll just make your life a lot easier, and the reason why is here. So what I'm going to do now is I'm going to save as, and I'm going to do save as a copy and continue. And so that was my case bottom, but now I'm going to save it as case top. Alright, so just to make sure that I'm not still working on the bottom case, I have my assembly here. I'll save my assembly. See, in my assembly, all these are updated already. I'm going to open up that top case. So, opening up top case. And so, now all I really need to do is, I won't have these tapped holes because these will be through holes, so I'm just going to delete these, right? I can delete this sketch also. I'm not going to need that one specifically. And so now I want to change this boss extrude. So instead of having that face as a surface, I want this face as a surface. Okay, so now they're just up to there. Now I want to change this boss extrude, and instead of 2.375 inches, I'm just going to make it up to surface, and I want it to go up to this surface. And so, just like that. Okay, well, I didn't like those cut extrudes, so that's totally fine because everything is concentric to each other. So, that's totally fine. Let's just make new circles. It's perfectly fine. Let's do center 2, and let's find those again. There. Okay. That one was right in the middle, and this one goes off of this edge. There it is. Okay. And then we do again, 1 inch. Alright. This one might be 2 inches. Right? And this one might be 3, depending on how you're making your gearbox, you know? Alright, so everything's happy now. And there you go, that's your top case. Alright, so we save that. Now we're going to close this, and let's open up our assembly again. So we're going to do gearbox assembly, open that up. And now we're going to insert component. And I'm going to bring in my case top. And then I'm just going to set it up here for right now. And then I'm going to mate. Let's move this a little bit. So I'm going to mate this face to this face. And I'm going to make this hole concentric to this hole. And then just for fun, I'll do this one to this hole. We should have no problems with mating at this point. So we're good, and we're good. Alright, so that's our top case, our bottom case. I'm going to open this back up. And let's make those holes. Extrude cut, or if you want to use Hole Wizard, you can use Hole Wizard too. But we're going to extrude cut, and then we're going to make holes here. Right. You can see why Hole Wizard would be a lot faster. But sometimes you want like a specific thing, you know? Maybe your CNC, you know, requires a specific diameter of hole, and so this is probably the easiest way to get that number. Now Hole Wizard's still faster. Alright, so we're going to make this 0.25. You find out what the through hole size is for your 1/4-20s. I'm just trying to go fast through this tutorial so I don't bore you. We're going to make all these equal. Boom. Here's the sketch. Through all. Check mark. Boom. Save. let's exit this one. Yes. And so now you have your tapped hole underneath. Man, I think it might be quarter inch. Um, and yeah, and so that's that. Now we would work on our hats. I'm going to work on that on another tutorial, a separate video from this one, just to kind of explain a little bit of what the hats do and what the purposes of them. But for the meantime, you're able to get started on your case, determine how to make your gear train. We'll go later on into some advanced mates to do the whole like gear mesh and make sure that they turn, and you can even attach your CVT and even your output shaft and your yokes and have everything spin beautifully. So we can go into that too. So hope it was helpful. Please like and subscribe to this video. Go check out Dr. Bachman's video on how to make gear in volute teeth. If you want to know how we do our gear calculations and how we determine our gearbox ratio, go check out the vehicle dynamics videos. There's one on powertrain where we talk about our MATLAB code that we use to determine our gearbox ratio. All helpful information. Please leave your comments. Please like. We appreciate it. We're trying to share the knowledge, so we really want to hear about what you and your teams do. So please comment and share this video. All right, thanks. Catch you on the next one.